This is our final lesson for our rationals unit, and we are going to focus on solving rational equations. So a rational equation is an equation containing at least one rational expression. Here are the steps to solve a rational equation. You have to factor the denominators and then identify all non-permissible values. Then we're going to multiply all the terms by the LCD and then solve by isolating your variable. And then you want to check your answer in the end. And in this case, when you're checking your answer, just make sure that your answer is not an NPV. So let's go ahead and do a few examples of this. So our first step is to factor the denominators, but in this case, there's really nothing for us to factor, so I'm going to leave that as is. Our NPV here is going to be x equals 0, because if we had 2 times 0, 10 times 0, we're going to get 0 in the denominator. Now we're going to determine what the LCD is, so then we can multiply each rational by the LCD. So we have a 2x, a 5, and a 10x so far. It looks like our LCD would be just 10x, because I can get a 10x if I multiply 2x by 5. I can get a 10x in this one here if I multiply this by 2x, and then our last one already has a 10x. So that's what our LCD is going to be. We're going to multiply each term by the LCD, and we're not going to multiply top and bottom by the LCD. We're just going to multiply each term by the LCD. Like that. The reason being is that we can do this because we're essentially multiplying by a 1 because there's an equal sign in here. Now you couldn't do that if there was no equal sign. If it was like a plus or a minus in here instead, like that, then you can't do that. But because it's an equal sign, we can. Because we're being consistent of what we're multiplying each term by. And now we're going to simplify, and we did this to get rid of our denominator. So for this one, we're going to have 10x over 2x. And eventually you can see that we can cancel some things out here, and we're going to be left with just a number and no variable and no fraction either. So in the next one we have 20x over 5, and that's equal to 10x over 10x. Now we're going to go ahead and simplify. So our x's cancel out. X divided by x is just 1, 10 divided by 2 is 5. 20 divided by 5 is 4. We still have an x here. And then lastly, 10x over 10x is just 1. Now we're going to rearrange and solve for x. So I'm going to move this 1 to this side, so it becomes -1, and then move the -4x to this side. So we have 5 minus 1, which is 4. And then we have positive 4x here. Last, we're going to divide both sides by 4. X is equal to 1. And that would be our final answer. And x equals 1 is not an NPV, so that would be our answer. And if you weren't sure, you could also plug this x equals 1 back into the equation to make sure your left-hand side of the equal sign is equal to the right-hand side of the equal sign. Okay, moving on to the next one. Again, we're not going to factor the denominators because we don't need to do that, but we can state what the NPV is. That's x equals 0, and your LCD in this case is just going to be x squared. Because this one becomes an x squared if I multiply by x top and bottom, this one could also have a denominator of x squared if I multiply top and bottom by x squared. Okay, the next thing we're going to do is multiply each term by the LCD. It's going to look something like this. We're going to have 5x squared over x plus 6x squared over x squared is equal to 6x squared. Again, remember we're only multiplying by the LCD to the numerator of each. Okay, now we're going to simplify. So this is going to become 5x, because x squared divided by x is x. Our next term is just going to be left with 6, and then we still have a 6x squared here. I'm going to rearrange because we have this 6x squared, which means we're going to have to factor. And it looks like in this case, we're going to use our quadratic formula. So that's negative b, in this case it's just positive 5, plus or minus b squared, negative 5 squared, minus 4ac, all over 2a. So we have 25 on the inside plus 144 all over 12. So then that's the root of 169 over 12. Root of 169 is 13. So then our two answers are going to be 5 plus 13 over 12, which is 18 over 12, and also 5 minus 13 over 12, which is negative 8 over 12. And then we can simplify this to have a reduced fraction. We would get negative 2 over 3 and also 3 over 2. Moving on to the next example. Here, because of the format of this rational equation, we have a rational equals a rational. And whenever this happens, we can actually do a shortcut, which is just cross multiply and divide. And this is only okay if you have a rational equals a rational. If you had a rational equals a rational plus another rational, you would not be able to do this. So when we cross multiply, this negative 3 is going to multiply with this x minus 2, and then 3 is going to multiply with this x plus 2. So now we're going to have negative 3, x minus 2 is equal to 3x plus 2. I'm going to distribute this negative 3, so that's negative 3x plus 6, and then 3x plus 6 here. Looks like our 6 is going to cancel out, because if I move it to the other side, that's 6 minus 6, and then we'll be left with 0 on one side. We can add 3x to both sides. We're going to get 6x, so that means x is equal to 0. For our NPV for this one, it would just be x is equal to plus or minus 2, and because our answer is x equals 0, it's not an NPV, so we're good. Okay. The next one. So we do have a rational equals a rational here. You can cross multiply if you wanted to, but I honestly think in this case it's going to be a little bit uglier if you do that, because we will be working with x squared and even x cubed. So in this case, because we have an x squared in the denominator for one of them, I'm going to use the steps that we've been using before, that I want to find the LCD and then multiply both sides by that LCD. First, I'm just going to state the NPV. For this denominator, this would be a difference of squares, so that's x plus 3, x minus 3. So that means for our NPV, it's going to be x equals plus or minus 3. And that would, x plus 3 and x minus 3 would also be your LCD in this case. Because the other one already has an x minus 3. So I'm going to multiply both sides by the LCD. And it's going to rewrite it so it looks neat. Now I'm going to go ahead and simplify. So these are gone, and then one of these are gone. I'm going to write down what's left over. and then simplify. So on our right hand side, I'm going to simplify this by expanding. That's x squared plus x minus 6. I'm going to rearrange and then see if we can factor this. So I'm going to subtract 7x on both sides. So we're going to get a negative 6x and then add both sides for 15, which is positive 9. Okay, we can try to factor this now. Looks like x minus 3 all squared would work, which means our solution would be 3. Now, x equals 3 is an NPV, and we can't have that then. So in the end, we just have no solution. Okay, moving on to E. Similar to D, I'm going to factor our denominator here. And most likely will be the LCD too. So if I factored this, factors of 35 are 7 and 5, and get a negative 12, we had a negative 7 and negative 5. And this works out perfectly for LCD because this one already has this x minus 5. Okay, and then our NPV then is x equals 7 and 5. So I'm going to multiply both sides by our LCD. And then we're going to simplify this. So these are gone. X minus 5 is gone on that right side. What we have left over is just negative 10. And I'm going to expand this. X times x minus 7 is x squared minus 7x. Then you just rearrange and factor. So factors of 10 are 5 and 2. You can achieve a positive 10. If we multiply those two together, we can have a negative 7 if we had both a negative 5 and negative 2. So that means we have x, sorry, some arrow here. X is equal to 5 or 2, but we're going to discard 5 because that is an NPV. So it's just x equals 2. Now for our last example. I'm going to factor this first. Factors of 24 are 6 and 4, and we can get a positive 10 if they're both positive. And that is going to be our LCD because you're going to have x plus 6 in one and x plus 4 in the other one. Then your NPV is going to be x equals negative 6 and negative 4. Okay, I'm going to multiply each of these rationals by our LCD. It's going to look fairly long, but I'm going to write it all out so it looks more neat. So that's from your first rational. It's from the second rational. And then lastly, do you need to go through this step when you're actually doing your work? You don't have to write it all out like this. You can just simplify right away. I'm just writing it out just so you know what I'm doing. Okay, so from here we're going to simplify. So x plus 6 can cancel out in the first one. X plus 4 can cancel in the second one. And then lastly, x plus 4 times x plus 6 can cancel out. I'm going to write down what's remaining. Now we're going to expand on the left-hand side. So this is what I'm going to multiply out first, and then I'll multiply this one out. So this is going to be x squared plus 5x plus 4 for that first one. After I expand, x minus 2 times x plus 6, that's x squared plus 4x minus 12. And then now we want to collect our like terms. So we have x squared plus x squared, that's 2x squared. 5x plus 4x is 9x. 4 negative 12 is negative 8. And then we're going to get this all on one side. So we have 9x minus 11x is negative 2x. And negative 8 minus 32 is negative 40. Okay, we want to factor this. I'm going to pull out a 2 and factor that out first. And then I'll factor this. So factors of 20 are 5 and 4. We can get a negative 1 if we had a negative 5 and a positive 4. So then our final solution is going to be 5 and negative 4. Checking our NPVs, we cannot take negative 4. So your only answer is x is equal to 5.